Hey, welcome back to Math with Patrick. Today is July 21st, and we're solving problem number 202 from the Daily Epsilon calendar. And like in other episodes, we are joined by Quill, who is going to help us solve this problem today. All right, looks like just an equation where we're solving for x. Although the equation itself seems kind of hard. Like we have a fraction on the left-hand side, x squared over 2 minus root 4 plus x, all of that squared, and that's going to be equal to x plus 28. So I'm noticing that there are some domain restrictions going on over on the left side of this equation. Like, for example, we can't square root negative numbers. I mean, we can just use complex numbers if we really wanted to, but usually with this calendar, x is assumed to be a real number. And so I really don't want root 4 plus x to have a negative number underneath here. And so essentially, I want the value to be greater than or equal to 0 in there. And that just means that x needs to be greater than or equal to negative 4. Because like if I do plug in a negative 4 here, I get the square root of 0, which is totally fine. But if I plugged in anything less, then I'd start to run into those like complex number issues. I also have a fraction on this side, and so I can't let that denominator equal 0. So I'll just actually set it equal to 0 real quick just to see what happens. I could say that root 4 plus x needs to be 2 to get a 0 in the bottom. I could square both sides, and then that shows me that x being 0 is an issue because then that makes us divide by 0 overall in the denominator there. Oh yeah, and once we square 0, we still get 0. So I also know that x cannot be equal to 0 for this equation to have any hope of being equal. And of course, we both know that the answer is 21, so it's good that 21 satisfies both of those conditions. All right, let's try solving it. My first inclination is to just get rid of that denominator. So I'm going to multiply both sides by the denominator, effectively just moving it to the other side of the equation, 2 minus root 4 plus x, and then squared. I have two thoughts for the next step. Maybe I'd want to square root both sides. It would be a little bit convenient because I get rid of like some of these squareds, but I would just be producing more square root signs, and usually that's not the right thing to do when solving for x. Squares and square roots are opposite, so I want to try to expand that left factor and see if I get anything good once I kind of rewrite it in that expanded form. So when you square a binomial, we need to do first times the first. That's going to be 4. Then we're going to do twice the first times the second. So I'll do minus 4 root 4 plus x. And then we are going to do the last times the last. A negative times a negative is a positive, so that's why this is a plus. And then multiplying a root by itself just gives you whatever is underneath that square root sign. So I've now expanded out that term on the right. I could simplify it a touch. This plus 4 could merge with that 4, and so we get 8 over here. And then I guess that plus x just kind of needs to hang out for now. And what to do now? I could expand more stuff just to see what happens. This might prove useful or it might be completely useless, but let's just see what happens. I'm going to multiply this x to all three of these terms and then the 28 to all three of these terms. And at this point, I'm going to reach for my calculator because I don't really want to do 28 times 8 in my head. So x times 8 is 8x. X times that mess, we'll just introduce an x in there, kind of like that. And then x times x is x squared. And then 28 times 8 is 224. 28 times 4 is 112. So that's minus 112 root 4 plus x. And then finally, we have a 28x from these two terms. And that entire kind of sum and difference, because we have some things being subtracted in there, is still supposed to be equal to x squared on the left. So I guess it's kind of convenient that we could cross off these x squared terms, I guess. So I'll get 0 equals, and then how about let's collect some like terms. We can combine the 28 and the 8 to get 36x. That's this one and this one. Maybe I'll tack on that plus 224 because I just don't want to deal with that kind of square root term yet. And maybe let's merge them together again, right? Because I could do like minus and then 4x plus 112 and then times root 4 plus x. Okay. This seems like a little bit more doable. Now that it's equal to 0, all of these are like even numbers, and I think they're all going to be multiples of 4. So let me divide everything by 4. So I'm going to divide the left side by 4, which is still 0. I'm going to divide all my terms on the right side by 4, so we get 9x. 224 divided by 4 is 56. I could divide by 4 in here. And so this whole chunk right here is all one term because it's just like one thing being subtracted. And so I'm going to divide the 4 in here, and I don't need to touch this one. Just because, I mean, if there were like a plus sign right here, then yes, I would divide this guy by 4. But just kind of the algebra rule here is that you divide each term by 4. And so it'll be totally fine for me to just divide this left side by 4. X plus 28, and then root 4 plus x. Well, okay, if this is equal to 0, then this and that must be equal to each other, right? Because we have a positive part and then a negative part. So 9x plus 56 equals x plus 28 times root 4 plus x. And then I guess I could square both sides. And then I would get rid of my square root sign, so I don't need to worry about square roots anymore, so that's good. Whenever you work with these squares and square roots and you start either squaring or square rooting both sides, usually you should go back and check if the solution or solutions you get actually make sense. Because there's always weird stuff with like the domain, kind of like I was talking about up here with these domain restrictions. You might come across solutions that don't actually make sense for the original problem. So I'll keep that in mind when I start squaring both sides here. Looks like I will get 81x squared, and then twice these two multiplied by each other, which will be, I need a times 2. I'm just doing this on a calculator right now. 1008x, and then plus 56 squared, which is 3136. That's equal to the left side squared. So when I square this side, effectively, I could just distribute that square across the multiplication, and so it's going to look like that. So x plus 28 squared, and then the square root and that square cancel, and I'm just going to flip it around from 4 plus x to x plus 4 because I'm used to it in this direction. And it looks like now we have essentially a quadratic on the left side, set equal to a cubic on the right side. So not really exciting. I guess we're solving a cubic today. Like 400 or 500 years ago, most cubics were thought to be kind of impossible. I was just watching a video on like depressed cubics and solving those things. So we'll just see what strategies come up for today. I'm going to multiply or square yet another binomial, x squared plus 56x plus, and then 28 squared is 784, all multiplied to x plus 4. I am going to do an area model for these guys, and so I'll put my x and my 4 over there. I'll multiply all my terms, so x squared and x make x cubed. This is 56x squared. This is 784x. X squared and 4 make 4x squared. 56 times 4 is 224, and then I need that x. And then finally, 4 times 784 is 3,136, which weirdly shows up on the left side of the equation. So this quadratic must be equal to all of these terms in here that create this cubic. Although I can start canceling like terms. I could cancel the 3,136 Let's see what these two terms add up to. 784 plus 224 is 1008, which perfectly matches the 1008 on that side. There's something weird going on with this problem, I swear. Like, something about the question writers probably made it line up perfectly. Okay, and then the 56 plus the 4 don't perfectly line up with that 81, so they don't like just cancel all the way. But this is going to be pretty easy, I think, now. Because, 56 plus 4 is now 60. I'm going to set this equal to whatever's left on the left-hand side. All of my terms have x squared in it, so I could just divide both sides by x squared. And interestingly, from before, I know that x isn't 0, so I can actually, use this condition that I already proved earlier to be very confident that I'm not dividing by a 0 right here. So that's kind of fun. And on the left-hand side, I'll actually kind of divide each of these terms individually. Okay. We get 81 equals x plus 60. And then here it's very clear to me that we do indeed get 21. Okay, so let's actually see if it works, right? Because we didn't plug it in or anything. We didn't try. 21 squared in the numerator creates 441. A 21 right here plus 4 makes it 25. When we square root that, we get 5. 2 minus 5 is negative 3. And then finally squaring that, we get 9. And so 441 divided by 9 is 49. And so we should just check that x plus 28 is also 49. And yes, indeed, 21 plus 28 gives us 49. So there it is. X is 21. That's my solution for today. And it looks like there's just the one solution. At this point, when we were working with this cubic, I was assuming that we might come across up to 3 solutions, but it looks like it just reduces down pretty nicely. So there it is. Maybe there's more to explore. Maybe there's something interesting going on that I didn't quite catch, that the algebra didn't, show me. But as far as I can tell, 21 is the only answer. So that works out for today, and I'll see you tomorrow. Bye.